Well, so this lesson is around the area-related optimization problems. So here the question is, for example, there is a rectangle that is inscribed in a semicircle, and the semicircular equation has been given s square of 25 minus x square. And what I have to find out is the dimension of the rectangle such that the area is the largest. All right. So in this case, first what we got to do is, let's say, take the variables. So if I take this is x, this is corresponding y. Okay, so the corresponding area that we are looking for is the area of the rectangle is actually 2xy, because if this is x, the total length is 2x, and times y, that is your area. Now, since I know y is a square root of 25 minus x squared, so area is 2x times 25 minus x squared. So this is my objective function, and then let's see how we differentiate this and get the exact answer. So just to repeat what we just did, so the length of this is actually 2x, entire length of the rectangle, and y is this. So area is 2x times y, and because we know y is nothing but square root of 25 minus x squared, so you get this as the expression. Now what we do is we got the area expression. Now there are two techniques by which we have to find out the optimum. I can square both the sides and take a square as a function and differentiate it. That makes our life much more easier. And if you can see the solution exactly here, um, so within 2 to 3 steps you get the answer, which is same as when you go longer way using product rule. So when you differentiate using product rule, the steps I have shown here. So you equate that to 0, and what you get towards the end is x is basically 50 over 4, x squared is 50 over 4. And when you solve for x, it is 3.535. Also, you could have just done the square both the sides, and what you get is this expression, and you differentiate this part and you get the x value pretty much the same as what we got in the earlier part. So this is how you basically do the area linked optimization problem. So this is supply product rule, basic idea of the area concept of this part, little bit towards this function logic, like where you're replacing y with the actual x implicit function, I mean the explicit function. Now let's take another example. So here's another example where there is a rectangle that is inscribed in on a line basically. So there are infinite rectangles that are possible like that. Here, like I'm showing some of these. Now what you have to do is you have to decide the dimensions of this rectangle that is maximum, that gives the maximum area. So if I take this as x, this and this is y, and equation of this line that they have already given is 2/3, y is 2/3 8 minus x. Sometimes you got to find this equation. Now, what you do is you find out this area by multiplying x with y. So area is x times y. So that is what we got here. Replace y with 2/3 8 minus x. So that is this part. And if you open up the bracket, here we get this step. Differentiate. Derivative of 8x is 8. Derivative of x squared is 2x. Solve for x, you get x is 4. If you draw the sign diagram of derivative about 4, it is positive or negative, hence it is proving that's the largest area. So these are the area link problems, and I hope they're helpful.